The first data that we're going to prepare for extraction from the pipeline is the total duration metric. While nearly every CI server today makes it very clear how long a test suite takes to run, they do not all provide easy ways to explore this data over time or with domain-specific breakdowns, which we can add to our own custom metrics. There are two common ways to extract this data from a CI pipeline. The first is to request the information from the CI's API. This can be done after the jobs are done running, and it can be done either for every build or on a regular basis like daily or weekly. You can do this on the daily and weekly basis because this can be used as more of a review function. The second option is to do this within the build. In this case, we calculate on the fly during the test runs so that the logic for how to generate the metrics and store them is all within the build pipeline. By using option 1 via the API, we would need some way of knowing when a job is running or how to know which jobs to collect data from. We would also need to be able to authenticate to the CI server's API to make these requests. By using option 2 via the calculations, we need to be able to accept that the total time report will be less than the time spent by the CI server. That's because there will be overhead by the CI server that we won't be able to capture. Given that each of these processes has its pros and cons, we're going to choose option 2 today and calculate the total duration as a part of the job. This reduces the security risk of needing API keys, and one key detail here is that we will need this duration calculation to be stored regardless of if the test passes or fails. And the problem is that most CI tools will exit as soon as any one command fails. So if we try and calculate this in the same step that we run the tests, we risk that these will not play nice together and will actually lose this duration calculation. Instead, we will calculate the total duration in a separate step in a job that is going to act a bit like a teardown step, in that it will run at the end regardless of the status of the previous steps. This means we will need to generate the start time and store that in a way that it can be captured and used in later steps. This can get a bit tricky in different CI tools, since most of them do not guarantee the same machine between steps. But we'll use a little bit of a trick in GitHub Actions on how to store this between steps, and every CI server will have its own trick for this. So we're going to get started by exploring how to generate a timestamp on an Ubuntu machine by first running an Ubuntu Docker image locally so that we can understand the command. So in order to make sure that we're using the same type of computer as is being used on the CI, I'm going to try and use a Docker container. If you've used Docker before, go ahead and get to the command line and ready to use it. If not, I would suggest that you try out Docker Desktop. Here you can follow along for some instructions on how to install. I already have Docker for Windows installed, and so I'm going to open that up. Here I am in Docker Desktop, and I'm going to be looking at two specific aspects of this menu. The first is containers and apps, and the second is images. If you've never used Docker before, you can look at this a little bit like cookie cutters and cookies. The images are the cookie cutters. They provide the template of what a virtual machine or a container will look like on your computer. And the containers are the outputted cookies. They are the computers or the VMs that you can use. Now, just to be clear, VMs and containers are very different subjects, but at a high level, they both allow you to run a different operating system on your computer. And so I may use those words interchangeably, as I know that virtual machines or VMs may be more common to some people. So if I go and I look at my images, I don't have any cookie cutters. So it's going to be hard to make cookies. So the first thing I need to do is I need to go get that Docker image that I'm using in my CI server, that Ubuntu latest. I wish there was a way to do that here in the Docker desktop, but unfortunately we need to go to the command line for that. I'm on Windows, and so I can use PowerShell, but you can use lots of different terminals to do this. The way you'll know if Docker is properly installed for you to use is to just type in the command docker and see if any output comes. This output is its help text. It tells you what commands you can run. And one of the commands that you can run is a docker pull. So I'm going to once again just enter that command and see what help text comes out. In this case, it tells me that it wasn't able to run successfully because it needs at least one argument, and what the intention is, which is to pull an image or a repository from a registry. So what I need to do is docker pull and then the name of the image I want to pull, which is what we used in CI, so Ubuntu latest. Once I press enter, that may take a second to download, but what you'll do is you'll end up with an image on your local machine. Great. I now have this local Ubuntu image. I can see that by returning to Docker Desktop and seeing it, and there it is. Now I want to be able to create a running version of this on my computer so that I can use it. To do that, I can roll over the row and I can see the button for run. When I click run, I have the option to run that machine. It will give itself a random name and it will start running. And one of the things that I can do is I can actually go into the terminal on that machine by clicking on the CLI button. Here I am inside of the CLI, and I can do things like see what directory I'm in, pwd, or see who am I, which will be root. This tells me that I am not in the same computer as my personal laptop. So what I really want to do now is explore how I'm going to generate timestamps on an Ubuntu machine. There's a command that we can use that's built in that's called date. Date provides us with the current time and day that we're running this command. And that's fantastic. That's exactly what we need. But that is looking a little bit too human readable to be useful in our scripting. What we actually need is a way to be able to do math. And right now, using date like that, we wouldn't be able to do the math. I can prove that by storing this into a variable. So if I create a variable and I try and store the output of a command, so I'm going to use $ open parentheses to run the command date and store its output in a variable called start. If I echo the variable start, I will get that same date. And if I try and do math on this, so if I say expression or expr of date, or the output of date, minus the start, this would be saying current date minus the start date. And we get a syntax error with the unexpected argument of oct. That's quite obviously because we have this text-based date. What we really need is something we can do math on. So we need to change how we format this date. Luckily, that's something that date can do. So if I run this command date, I can use a flag in order to change the formatting. And that flag is using the character plus and then passing in the format that we want. The format we're looking for is %s, which basically says I want a seconds count from a specific time. So this is how many seconds since January 1st, 1970, which is a agreed upon standard way of describing time today. Now all of a sudden, I think I can do math on this. So what I can do is I can save the current seconds into my start, and I'll call it start seconds. And I'm going to save it the same way by running the command in a $parentheses run date plus parentheses s, or %s. And I can now do math on that by saying expression current date plus %s minus start seconds. All of a sudden, you can see that it took me 16 seconds to go from the start time to the end time. This is how we're going to be able to extract current time from the Ubuntu machines that are running our pipelines. We can now exit this by just clicking the X, and we can even delete the Docker image by hitting the trash sign. We can always create another one if we need it. With all this planning done, it's time to start calculating this in our GitHub action. Close this to get a little bit of screen real estate, and I'm going to scroll down and look at my job. So I'm going to use some code comments, just like I've done before, to describe what it is I want to achieve. So the first thing I'm going to want to achieve is to set a start time. The last thing I'm going to want to achieve is at the end of all of this to calculate total duration. And I want to make sure that under here, make sure to run even if a previous step fails. We're going to have to learn how to configure that. So if that's what our goal is, we can start with setting a start time. And to do this, we're going to need to run a custom step again. So that means that we can give it a nice name. So in our case, it'll be set start time. And we're going to need to give it a run command. In this case, we're going to want to use the same date command we were just using in our Ubuntu Docker image. So we're going to want to say start time equals $ parentheses to run the command date plus %s to get that in seconds. But the interesting part here is that we need to somehow make sure this gets stored by GitHub. And to do that, we actually need to echo this entire command out and write it using these two chevrons to the GitHub env. And this GitHub env is sort of magical in that it will store things for us between steps. So now that I've set the start time, I need to move on to calculating the total duration. For this, it is once again going to be a new custom step. And in our case, I'm going to call it collect build metrics, or build data more specifically. And inside of here, I'm going to once again do a run command. And what I'm going to do is I'm going to run the exact same command I ran in Ubuntu. I'm going to run an expression that takes the current date in seconds format and subtracts from it the start time, which I can access via the environment variables like this. By using the $, I'm saying I'm getting an environment variable, and by using this curly braces, I'm saying that the word inside of that is the variable name. So start time. This should print to the screen my total duration. But we still need to do this making sure that it runs with even if the previous step fails. And to do that, I can introduce another characteristic of this step, and that characteristic is the if characteristic. And I'm going to say that I want to always run this step, regardless of previous step status. I'm ready to commit this into my repository and see this run on GitHub Actions. I can do that via IntelliJ. So under commit, I can see that my actions.yaml has changed, and I have written a commit message previously about this. So I can commit and push. Once that's been pushed, I can return to the browser and see it running. Here I am in the Actions tab of my repository, and I can see that the commit I just ran has started running a new workflow. I'm going to click through and watch that run. I'm going to speed this up for ease of watching. Here I am with our tests having ran. I see that the tests for Maven have failed, and so I'm just going to go check out and make sure that nothing is different. We know that there's a failing test there, and I just want to see that that's still the case. So again, we have 23 tests run, we've had 2 fail, and I can see that the ones that failed were the window test and the forgot password test again. So that's a known failures. Soon I won't need to click in there because I'll be able to see that elsewhere, which will be great. But we can also see that I've introduced 2 new steps. set a start time step, which ran this echo, and collect build data step, which ran the expression and resulted in 64 as the answer, 64 seconds. We can see that the build and test took, in total, actually 67 seconds. We talked about this as one of the drawbacks of collecting data in this way. But in my case, this is good enough for now, and so I'm going to consider this complete. Next, we're going to look at collecting even more interesting data and eventually pushing that to Prometheus so that we can explore it through querying.